There's something just magical about a great glass of wine, right? The color, the smell, all those complex flavors. It totally feels like art. But what if I told you that behind all that art, there's this incredible world of science? Well, today we're going to pull back that curtain and see what's really going on.
All right, let's just dive right in. Because what's inside that glass? It's so much more than just fermented grape juice. I mean, it's a bustling, microscopic world, a really complex chemical soup that winemakers have to learn to control with just incredible precision. And that right there brings us to our first big topic, this massive challenge of what scientists call oenological analysis, which is really just the science of wine. I mean, think about it. How do you even begin to map an entire universe that fits inside a single glass?
And no, that's not an exaggeration. We're talking thousands of different chemical compounds swirling around in there. Every single one contributes something to the final taste, the smell, the texture, the whole experience. Some of them create those beautiful floral notes you might smell, while others give it that perfect acidic kick, or that structure from the tannins. The winemaker's job? It's basically to be the conductor of this tiny chemical orchestra.
So for a long, long time, the tools winemakers had to figure this out were, well, pretty basic. The old-school lab methods were just so slow. They couldn't handle a lot of samples, and honestly, they weren't sensitive enough to pick up on those really subtle compounds, the ones that make the difference between a good wine and a truly great one. They just didn't have the precision that modern winemaking demands.
So how do modern labs get it done? Well, it's not as simple as just testing the wine. Before you can analyze anything, you have to find the specific clues you're looking for. It's kind of like the detective work of wine science, and the official name for it is sample preparation.
Okay, so what does that mean? Well, to put it simply, you can't just pour your glass of wine into some multi-million-dollar machine and press go. Nope. First, you have to isolate the specific compounds you want to study. It's this absolutely crucial first step. You're cleaning up the sample, you're concentrating the molecules you care about, and you're getting it all perfectly ready for the high-tech gear.
And you better believe there are strict rules for this. The best way to think about it is like a forensic scientist handling evidence at a crime scene. Rule number 1, you can't lose what you're looking for. You also have to get it into just the right physical state for the machines. And maybe, most important of all, you absolutely cannot contaminate the sample or let other stuff interfere. Because if you get this part wrong, all your results are completely useless.
And just look at how these techniques have evolved. On the left, you've got a classic method, liquid-liquid extraction. That's pretty much what it sounds like. You use one liquid to pull certain compounds out of another. But on the right, that's something that feels straight out of science fiction. It's extraction using something called supercritical fluids. This is a wild state of matter where a substance acts like both a gas and a liquid at the same time. It lets scientists pull things apart with incredible precision.
Okay, so once our sample is perfectly prepped, the main event can finally begin. We like to call it the Great Compound Race, but its scientific name is chromatography. And this right here is the core technology that scientists use to separate that super complex mix of molecules.
The basic idea behind it is actually pretty brilliant. You've got this jumble of compounds, and you essentially make them race each other. To set up this race, you just need 2 things. Something called a mobile phase, that's a liquid or a gas that carries everything along, and a stationary phase, which is a solid or a liquid that, you guessed it, stays put.
So here's how the race actually works. As that mobile phase, the carrier, flows over the stationary phase, some compounds in the wine sample are more attracted to the stationary part. They kind of stick to it for a bit, which slows them down. But other compounds, they prefer to hang out in the mobile phase, so they get swept along super quickly. And just like in any race, everyone finishes at a different time. And that, my friends, is how you separate them all out.
Now in winemaking, they really use 2 main types of this technique. First, you've got liquid chromatography, or LC. This is perfect for all the stuff that's dissolved in the wine. Think sugars, acids, and tannins, the building blocks of flavor and structure. Then you've got gas chromatography, or GC. This one is for what we call volatile compounds. That's just a fancy way of saying molecules that turn into a gas really easily, which of course is how we smell things. So GC is absolutely key for analyzing those delicate aromas and also for a really important job, detecting unwanted stuff, like trace amounts of pesticides. So let's take a look at how liquid chromatography actually works in a real lab. This machine right here is a high-performance liquid chromatography machine, or HPLC for short. And this thing is the absolute workhorse of any modern wine lab. It's an incredibly powerful tool for analyzing all those components that create taste and texture.
What it does is take our perfectly prepped sample and blast it through the system under super high pressure, making that race happen with unbelievable speed and precision.
So let's break this complex-looking machine down. It's actually pretty simple. First, the injector is what introduces our sample into the system. Then you have the column. That's the all-important racetrack where the separation actually happens. Next up is the detector. Think of it like a super-sensitive finish line camera that identifies each compound as it crosses the line. And finally, you get the chromatogram. That's the final printout, a graph that shows the scientist exactly what was in the wine and how much of it.
All right, but what about the other side of the story, the aromas? For that, we turn to this, a gas chromatograph. Its whole job is to analyze those volatile compounds we talked about, the ones that create a wine's bouquet. The principle is exactly the same. It's still a race, but this time all the equipment is built to handle gases instead of liquids. And it's a critical tool for figuring out why one wine smells like citrus and another one smells like dark berries.
So here's how this one works. A gas cylinder provides a gas like helium. That's our mobile phase this time. An oven then heats up the sample, turning it into a vapor so it can start the race. That race happens inside this really long, super thin coiled tube called a column. And at the end, a specialized detector senses each and every aroma compound as it comes out. So you see, the whole process is really similar to the HPLC. It's just designed for the things we can smell.
But what if you could take it a step further? What if you could go beyond just separating aromas and actually teach a machine to smell? Well, that brings us to what is probably the most futuristic part of this whole story, the rise of the digital sommelier.
Just take a look at this. It shows how an electronic nose, or e-nose, works by basically copying our own sense of smell. See on the top? That's how our nose sends signals to our brain. The e-nose on the bottom does something similar. It uses an array of different chemical sensors that react when aroma molecules hit them. The machine then takes all those signals, processes them, and creates something amazing, a unique olfactory fingerprint. It's like a digital signature for that specific wine's aroma profile.
Okay, so we've seen some seriously incredible technology. But let's bring it all back. Why does any of this complex science actually matter to you? How does all this high-tech work in a lab translate to the wine that's in your glass?
Well, here's the payoff for your palate. First up is quality. By understanding wine at a molecular level, winemakers can literally pinpoint the exact compounds that create those perfect flavors and aromas. That leads right to consistency, making sure every bottle of that wine you love tastes exactly the same time after time. Then there's safety, which is huge. This tech can detect even the tiniest amounts of stuff you don't want, like pesticides. And finally, it all drives innovation. It gives winemakers the hard data they need to experiment and create brand new, exciting styles of wine with confidence.
This table here does a really great job of summarizing what the scientists are hunting for. You can see how those different types of liquid chromatography are used to find everything from sugars and phenols, the things that give wine its taste and color, all the way to vitamins and amino acids. And then you see gas chromatography at the bottom, the go-to tool for all those beautiful fragrances and, of course, for those crucial safety checks for pesticides. It's all part of a super targeted, highly specialized process to build a complete profile of what's in that glass.
So, in the end, it turns out the art of winemaking is truly powered by some pretty deep science. It's this amazing fusion of tradition and cutting-edge technology, and it's all aimed at one thing, creating that perfect experience in your glass. So the next time you raise a glass, maybe you'll think about the incredible, hidden universe of science that's behind that single sip.